much.
All right, so I will start sharing my screen. Yes, here is it. So you should be able to see it now. All right, so today we're going to talk about Git, Git, which is a version control tool, and we'll explore the basic command line options we have with this software. So my name is Eric Breo. I'm a developer, and well, I basically use Git every day, as many of us. That's the main tool for managing source code. So first of all, we'll try to understand why we do need version control, because it's not necessarily obvious. Well, obviously, we need to be able to save our code. When you are working on a development, you will have many files, and you will progressively improve the software, change the features, etc. And obviously, you cannot afford losing all of that. If you just have your code on your machine and nowhere else, you would be exposed to a great risk if you are not able to save it somewhere, of course. So that's one thing, saving the code. And we could do that by just, copying the code regularly and putting it somewhere in an archive. Of course, we could do that. But something else that allow version controlling is it allows to come back from the current version to a previous version, or to switch between a main version and an ongoing development. Why is that? Why do we need this? Because when you are running software, running a project, you will be probably deploying a version at some point, so your users can use it. And well, you might have some requests to change something, to improve, to add a new feature. So you start implementing this feature, but in parallel, you might also have some bug in the production version. So you have to stop what you're doing, developing the new feature, which is not ready yet, and come back to the production version and fix the bug and then deploy it. So if you have to remember which are the new files for the new feature, which are the changes, where you did them, etc., it takes, it's absolutely impossible. So that's also something your version control system allowed to do. So with Git, you might say, okay, I want to go back to the prod version, and now I want to switch back to the feature I am currently developing. And it will manage all the changes you want in the code. Another important aspect of Git is it allows to get an history of any section of the code. When you've been working like 2 years or 3 years on a software, there are some part of the code you might haven't touched for months. So you do not necessarily remember why you put this instruction there and not another one. And you wonder why is that? Why do I have this there? Because now I'm fighting a bug, which is probably caused by this line, and instead of just removing it, you have to understand why you did it in first place. And with your Git history, you will be able to see when you did this change, like 6 months ago, and you will see a comment associated with the change saying, okay, I'm fixing this bug. I'm fixing this behavior. I'm changing this feature. And then you can understand, okay, it was important in such context, and now I have this bug in such other context. So yes, I have to fix the bug, but I should not break the initial use case. That's also something you will be able to know from your version control system. And of course, last point, it allows team collaboration. It allows you to exchange your code, merge code from different developers, like you work with a team, or you work with external developers collaborating on the same project as you are. And well, you obviously want to be able to merge into a single version all the contribution from the different person involved. So that's basically what you can do with such a system. Now, there are several solutions to do that, and Git is only one of them. Why do we use Git? Why am I talking about Git today? Is because that's the most commonly used system for it. And yeah, it's used everywhere. Everybody knows it. And if you have to use something similar, the knowledge you will have about Git will help you anyway, because they are all kind of referring to how Git is working. So that's one of the reasons. Another reason is that it's open source, so it means it's free. You can get Git and run it on your machine for free, and you will get updates, etc. So that's obviously much better than having a commercial system you have to pay for. And also important to mention, because of GitHub. GitHub.com is a platform where, let's say, developers are socializing, kind of. That's basically the place where people can expose what they're doing. That's where people can ask questions, understand the code, push contribution, exchange the code, basically. And it is, I mean, GitHub is not connected to Git itself. GitHub have been created to offer a remote server for any Git repository, but it has been extremely successful. So now it has been kind of shaping the habits of the developers, and that's basically why we are there now. And let's be clear about it. Yes, it is difficult. It is difficult, and we could wonder why it is so much more complicated than just managing documents on the file cloud. Like, I mean, for anybody having some documents, we know how to push them to a cloud like Google Drive or OneDrive or whatever it is. And it's actually easy. Everybody can do that without any developer knowledge. Why would it be any different with source code? Why is it more difficult? Well, what it does, is difficult. Imagine if you had to exchange and merge code manually, like someone in a team create 300 lines of code in 20 different files, and you did the same, and at some point you should merge all of that. If it's not automatically done, it's super difficult. And that's not something we do usually when managing just documents. Documents are usually a single thing. It's not several files. And we are not making so many changes all together within a team. So the feature itself, what we aim to do is difficult. And then it's not that surprising that the tool itself is difficult. But to be honest, Git is not the easiest solution. There are easier way to manage version control. Unfortunately, as I said previously, Git is the most commonly used. So we have to bear with it, basically. Something important though, remember that it is difficult for everybody. Everybody needs to check on internet the most basic use case permanently. I do that. I mean, I've been using Git for more than 10 years. And I still checking regularly in the documentation how to do this, how to do that. And that's totally okay. That's totally okay to ask for help. Git is complex. Everybody knows that. So there is no shame in saying, oh, well, I'm lost. I don't know how to do that. That's totally accepted. Now, I will get into the most important comments. There are a lot of comments. I will not go into all of them. I don't think I know all of them, and I certainly don't need them anyway. So I will go through the most important ones. And every time it's relevant, I will try to do a visual demo so the concepts are clearer, because yeah, the concepts are not necessarily easy to get. So first you have to initialize a repository. So a repository is basically the place where you're going to save your code. All right. So if you have a development project, it's probably within a folder. In this folder, you will run git init, and it will initialize the Git repository. What it does technically is just creating a subfolder, which is hidden, named .git. And that's, you can see that as a database where all the changes will be recorded. And that's totally transparent. The rest of your code, your subfolder in your project, etc., will be untouched. There is nothing there. You can continue writing code, etc., but you can benefit from the Git features. So that you start that way, Git init. Then, well, you will probably start creating files, make some code, any kind of code. The way you save your code, the way you are telling Git, this is such change, and please save it for me, is by adding the file. So you add one file or several of them. You can add as many as you want. So that's a git add command. And then you commit it. So you commit the file, and you are supposed to add a comment with that. So you do git commit and -m with your comment. And your comment is just an explanation of what it is about. And you are encouraged to do a nice message, because you will be the one reading it in 6 months, wondering why you made this change in such file with just a comment, fix it, or improvement. This is not good enough. Most part of time you will need more information. So that's at the time you are creating your commit that you are supposed to describe precisely what it is about. So yeah, let me show you how it goes. So I will go to a demo website where it is actually simulating a Git repository. I will not be modifying files. It just considers that there are some files modified, and I can commit them. So here I am on my main branch, and I will explain later what is a branch, and I can commit. So add new logo, for example. I'm creating commit because I have added a new logo for my project. So now you see I have another commit. You see there was an initial commit, and now I have a new one. And I can maybe add another one. So like it will be add login page. Oops. Hey, come on. Sorry for the typo. Here we go. So the commits goes one after the other like this. Every time I do something which is meaningful, I will make a commit. Oh, sorry. Another way to save code. Oh, yeah, sorry, I haven't mentioned something important. When you do a commit, what you do is saving the change you just did. Like you add, I don't know, a screen with a button, and you add a new button. So now there is 2 buttons. You make this commit, it will save all the files where that have been impacted by this change, adding a new button somewhere. But the commit itself is actually a snapshot of the entire project. If you are coming back to a previous commit, it will restore all the files in the state they were at the time you made the commit. Okay, so it's always consistent. You don't have to manage a commit per file. That's super important. Like if now, let's say I move back to my commit, I will explain later how we do that. If I go back to C1, my first commit, now I see the project exactly how it was at the time I made this commit C1, okay? Oh, sorry, I'm going too fast. So yeah, by doing that, I save in this kind of database my changes. But sometimes you have some ongoing changes that you're not ready to commit. Maybe you haven't finished something. Maybe you need to switch to another version and do some change, and you don't want to commit immediately what you've been doing. You can use Git Stash. Git Stash will just put them aside temporarily, and then you can restore them when you're ready with Git Stash pop. So yeah, that's an interesting feature when it's like a draft. Let's say, yeah, it's working exactly like a draft. So that's basically the two options you have to save your code. Now you need to know where you are, what have been the different changes. And for that, you have Git Status and Git Log, which give you information about where you are. So let's do that here. I call Git Status. And here in the terminal, I will see in which branch I am, which are the file currently modified, and if I need to commit something or not. If I do git log, I will get the list of all the commits from the most recent to the oldest. So yeah, my latest commits was add login page, and I can see the date and the author. Then the previous one was add a new logo. Here again, the date and the author, and etc. So that's a way to know what have been the different changes. And it's also giving me the reference of the commit. Like here it's C1, C2, C3, etc. In a real system, this one is totally fake. In a real system, it's a more complicated identifier, super long, that you cannot remember. And that's a good way to find it back and copying it. And then you can move back to this commit when you need to. Now, you can also do tags. Commit, as I said, are just a reference, which is difficult to remember. Here it's just C3, C2, etc. And a comment, just a comment. Like here, it was add login page, add new logo, etc. Sometimes it's useful to say, okay, the way it is right now, my project is perfect for this, or is reaching this point where I can say that's version number 1 and it's ready for production. So you want to add a small tag so you can remember it. So let's say that's version 1, and I will name it git tag 1.0. Okay, that's my tag. And now I can also add another tag, like tag, let's say, prod ready. So I can add as many tags as I want, and that's just, let's say, a shortcut to remember a commit. That's all what it is. And that's usually we use it for versioning, like when version, let's say I add a new commit, and I can tag it as version 101, for example. Here we go. So now I have an easy way to come back to any version number I want. So if someone tell me, okay, we have a production, an issue on production with version 2.05, I can just check out this version and see how it goes. So that's labeling, basically, putting a label on the current state of the code. Reset. So reset is an interesting command because it allows to undo a commit. If something is wrong, you want to forget about it. You don't want to keep it in your history for some reason because it was not right. You can reset back to a point. Like, let's say version 101 is totally wrong. My C4 commit is making mistakes, etc. I just reset to version 10. And it moved me back to this state. And this one is forgotten. I can create a new commit. It will go after C3, and C4 is aside. It's not part of my branch anymore. So I can reset to a given tag. I can also reset to a given commit. Like if I want to reset to C2, there is no tag there. I can use the commit reference. Okay, here I am. So it's coming back in history, basically. And by doing reset, so here I don't have any file, right? So I just show how it moves in the history, but by doing reset to a given tag, it will preserve my code the way it is. It will just move back in history, but all the difference between the, for example, my version 1.0 and the current code are still there. They are not just not committed. If I do reset hard, then it will erase all those changes, and I will just go back to the code state exactly as it was in version 1.0. And I lose all my changes. Now, next concept is branches. For now, I've been working in a single branch, just adding commit one after the other. But as I said in the introduction, sometimes it's not good enough, because the typical use case is you have a version in production and you start developing a new feature. So you want to keep your existing production version somewhere in order to be able to make fixes if you have to, but at the same time explore new things for your new feature. So you have to split the code, like being able to work on the future version while you are still able to work on the current one. So to do that, we make a branch. That way, we can peacefully develop something which is not ready yet, and whenever needed, come back to the main branch. How do we do that? First, we need to create a branch. So we do that by using the branch command, so git branch, and we give it a name, and then we check out this branch. But nobody does that. It's too long. We use a shortcut, which is git checkout -b and the name. So it does the two commands in a row automatically. So checkout -b is the first thing you do when you want to have a new branch. Let's go with that. So I will reset my example. So let's say I have a main branch, which is my production branch with some commit. And now I want to work on something different. So I will create my branch, which is feature 1. I name it the way I want, right? But I will name it fit 1, as it is my first feature I want to develop. Now I will enter this branch. So git checkout fit 1. So you see the small star is on fit 1, so it means I'm there. And I can start making some commits. So you have a new commit and another one. But now someone tell me there is a problem on production. So I need to go back to the main version and make a fix. So I will use the checkout command to go back to main. I see what the trouble is, and I fix it. So I fix my bug. So as you can see now, I have visibly two branches. So I have my main branch, which is C1, C2, C3, C6. And in parallel, I have C4, C5 apart in the feature 1 branch. So I can make as many commits as one on my main branch. It will not change anything in my feature 1 branch. And when I'm done fixing bug, I can go back to fit 1. So I check out fit 1. Okay, now I'm there, and I can continue working on it, improving my new feature like this. See, so we name it branch because obviously it's starting from a common trunk, and you split it. I could make a new branch for my feature branch, like I have started implementing my feature in a way, and I have maybe several alternatives to make this feature. So I want to try it out. I will create a new branch. So let's go with a shortcut, git checkout -b, fit, let's say, new login, let's say. Okay, so now I can make a commit here. And I come back to my feature one branch and make a commit. Here we go. See, that's branches. And you can have as many as you want. The thing to remember is you have a main one. The main one is usually the one you push to production, but it's not necessarily. There are several strategies for that, but you have something which is a reference where all the feature ultimately will come back to. So I have been already using this checkout command. The checkout allows to switch between branches. It allows also to switch between tags or commits. Any reference is valid. Like here, I can go to my main branch by doing git checkout main. But I could also go, I could just tag it. I tag it as prod one, let's say. So that's a tag. I can check out C2, which is a commit. And now I'm back to C2. And I can now come back to prod1, which is a tag. So anything is valid. It just allows me to move from one state of the code to another. So between branches, tags, or commits. That's a checkout command. Now, I haven't talked about merging. Sorry, sorry, I missed that one. Now the question is how to move the code between branches. As I explained, you have a main version which is usually on production, and you start working on a feature. But at some point, the feature is ready, right? So you want it to be integrated in your main version, in your main branch. There are different strategies for that. So one of the strategy is merging. So let's say I am on my main version, and I want to, I will say that feature one is ready. I want to merge it. So I do this, merge fit one. Okay. So what it does, it adds a new commit on my main branch, which is integrating all the changes from feature one. So it's a commit containing reference to other commits. And now my main branch is having this kind of loop here. See, that's a way to do it. So it takes all the changes, all the difference between my current state of main and the state of the code in feature one, and it applies the changes to my main branch. And now it's part of my main branch, and I can continue making some commit. Here we go. Okay. Another approach. So I will reset all of that. It's getting messy. So let's say I create a branch, feature one again, make few commit. So here are my two commits in my feature one. And then let's say that in my main branch, I have been, as I was working on feature one, I was also fixing bug on production. So I made also few changes here. So I have my two branches, the main one with two commit and the feature one with two commit. Instead of merging and then having a new commit into main to integrate C1 and C3, C2 and C3 in my main code, I could rebase. So by rebasing, it will, look at this, you will see how it goes. It will kind of copy my new commit in main after feature 1, and this will become my new main. So that's why I haven't been creating any extra commit. I just created a duplicate of C4. So that's C4 code and C5 code, which have been added after C3. And I can now create some more. So by doing this, it's much more cleaner because the history is clean. I can see all the changes in a row instead of having some kind of loops as we had with merge. So that's another approach, basically. I will not get into details of why we should do this or that, depending on the case. Just remember that rebasing is cleaner, but it might involve more effort when there are conflicts between files. That's basically what it is about. And another option to get some code from somewhere and move it somewhere else is by cherry picking it. So cherry picking is when, let's say, so let's reset. I have a branch. With some commits, and it's not ready to be merged. It's not, the feature is not ready, not at all. But I realized, so I made some changes in main, and then at some point I discovered that the bug I'm currently fighting on main is actually fixed by my C2 commit in feature 1. These changes need to be applied immediately, even though I'm not ready to merge the entire branch. So I can just pick it from the other branch. So I will just give the reference of the commit and see, it copied it. So that's a different commit. It looks like C2. It's actually the same content, the same change applied to the code. It's just added to my main branch, even though it was part of feature 1. Okay. So that's pretty handy when you have many change. You don't want to merge immediately because you're totally not ready, and you just want to get a small fix somewhere and move it there. That's cherry picking. Now, we're going to talk about remotes. So here I've been working only locally. So you are on your machine, you're managing some code, and you do those saving locally, but you are not exchanging anything with external people. That's what you can do with remotes. So first thing to do, well, there are two approaches. Either you start from an existing project, so you're not the creator of the project, right? Someone else started it already. It's somewhere. So on GitHub, for example, on GitHub here, I put a small screenshot of how it looks. If you go to a project, you have this code button. And if you click, you have this pull down where you see the address, the URL of the repository. You retrieve this remote repository by doing git clone and the address. What it will do is it will create a new folder by the name of the repository. So here is Nexus. It will create a Nexus project, a Nexus folder where you have the source code and all the branches, all the commits, all the history of the project will be there. So you can enter it and start creating your new branch and do stuff. That's when you are not the initiator of the project. If you are the initiator, you will start locally probably, and at some point you want to publish it. So you will go to GitHub and you will create a new repository, which will have an address as well. And you add it, you declare it locally using the git remote add origin and the address. So here you have several commands. You have remote, which means we're talking about remote repository, add to add, and origin is a name. It could be anything. You could name it GitHub or my server or whatever, but everybody is naming it origin. And as far as you don't have several, you'd be better naming it origin because if you don't, people get confused. But yeah, it's just an habit. It could be anything. So now you have this remote repository. You should be able to exchange code between the two. So when you want to get a remote branch locally, when you want to retrieve some changes from a branch, you do Git Pull. So I will demo that. So here I have my two projects. The one on the left is my local project, and the one on the right is the one on the remote server. Let's say GitHub, for example. As you can see now, I have my branches locally have two names: the actual names like main, and also o/main, which is a shortcut for origin/main, meaning that it is actually in sync with the origin version or the origin branch, so the one from the server. So let's make a commit. Here I have a commit. I have done it locally. It's totally not on my server. So that's why main and o main are distinct now. And let's fake some. So here, this command does not exist. The one I'm typing right now is just a way for this simulator to simulate the fact that someone else on the team made a change and push it to the server. So I have a C6 commit on my remote main branch. And this is an important fix. I want it locally because locally I'm not able to run the software anymore because I miss this fix. So I will do git merge. Oh. Oh, git merge is not. The simulator is not behaving as expected. No, I'm sorry. Oh, sorry. Yeah, I was using the wrong command. I will come to this difference later. So I need to do git pull. Sorry for the confusion. So here what it does, as you see, it is getting my remote branch the way it is. So you see C6 is in my O main branch, and then running a git merge, that's why I was confused, with my version of main locally. So it had a merge commit here. So I was on C5. It copied locally C6 and then merge it after C5. Now let's undo that. I will reset to C5. Okay. If I don't want to have this merge commit, just like I was explaining with a local branch later, I can do pull -r, which will rebase the changes. Oh, it's not supported. Oh, it's too bad. Okay, never mind. So I can do it manually. Okay, so now, the way I did it, instead of doing the merge, the direct merge with pull command, as you saw, you see the C7 commit still there. Here I have been copying locally C6 and I have added C5 after by duplicating C5. So it's a cleaner way to do it. So you do it with git pull -r. And now you want also to be able to push what you've been doing locally to the remote server so your team members, your teammates can benefit of it. So here I have my C5 commit, which is interesting for my team. So I will push. And it is duplicated on my remote branch. So then my colleague can pull on their side and get this change. So yeah, that's how it goes with remotes. So I know it's complex. I mentioned it initially. I will stop here with the comments. So we've been seeing Git init to create a repository, Git add and Git commit to save a change, Git tag to put a label on a given commit, Git checkout -b to create a branch, Git checkout just without -b to move from one branch to another or to go back to a given commit, a given tag, Git clone to duplicate a remote repository, Git pull to get a remote branch, and Git push to publish the code we have locally to the remote repository. That's basically what we use. Oh, and I forgot Git cherry pick to just take one commit. That's what we do 99% of the time. The other commands are not that useful compared to those ones, but you will obviously find them in the documentation. The important thing to know is even with the small set of commands, you will get into trouble. Obviously, you will. I do that every day. I'm into trouble with Git every day. So that's normal. Don't panic. It's okay. You can ask for help. You can always, I mean, it's never too late to fix something. If you are in a bad situation, you can always come back to the proper state of the code. You can always restore the version from the remote server anyway, as far as you haven't been forcing the changes, because there is a command I haven't mentioned, which is push -- force, which will override what's on the remote server, even though, I mean, by force, even though it's not mergeable for some reason. That's dangerous. Most part of time is disabled, so you are not allowed to do that unless you are the manager of the repository. So if you don't do that, for any other case, there is always a solution to come back to a proper state. Remember also that it's always better to commit than not to commit. So don't go that way by saying, okay, I will commit everything at the end of the day. No, it's not a good approach. Commit as many times as you want. Every time you do something which is interesting, commit it. You commit regularly. That's allow you to come back to any point in time. That's allow you to understand what the change you have been doing. And anyway, at the end, if there are too many commits and it's polluting the Git history, you can smash the commit altogether when you merge them on the remote server. So that's okay to commit a lot. And remember also that it's always better to use Git in a bad way than not using it. So that's fine. You will learn how to use it. You will create your own strategy to sort out problems. You will find information on the internet. I also recommend to go to the website I've been using to show you how it goes. This is learngitbranching.js.org. It's a demo site, but it's also offering some lessons. You can have some exercise, like if you go there, there's many exercises, so you can try your knowledge, and it's fun. It's a good way to learn. I started using it just because of this talk today. I was not knowing it before, and it's actually very fun, and I've been learning new things myself. So it's really good. It's good practice. So yeah, that's a reference to the website. So you can practice and have exercise and so on. And yeah, I think that's it. So thank you. I'm on time. So if you have a question, you're more than welcome. I will stop sharing my screen, I guess. Yeah, here we go.
Yeah, Eric, can you explain what Git Stash does again? Because that's kind of one I
Stash. Oh, yeah.
struggled with in the past.
Yeah. So stash is when you don't want to commit something. Like say when you have something done, like you created a new login page. So you make a commit with all the changes it involved, and that's done. But imagine you are just in the middle of the implementation of the login page. It's not even compiling. It's not properly done at all. But you need to switch back to the production version to fix an urgent bug. So by calling stash, it will just hide the changes. It will free you, so you cannot move to another branch if you have ongoing changes. If something is not committed, Git will not let you move back to something else. It will tell you, hey, you cannot move there because some changes are not saved. Just like when you are, I don't know, in Microsoft Word and you haven't saved the content you want to close, it would say, hey, save it before you cannot leave. Exactly the same thing. So a solution to save it is to commit it, but it will be a temporary commit that you don't want to keep the way it is. So instead of committing it, you just stash the change. And when you're done with your fixing or whatever it is, you come back to where you are and you do git stash pop, and it will restore the ongoing change. It's like a temporary commit, basically.
Thank you.
Welcome. So I hope I was clear enough. I know it's complex. I don't know if you had any knowledge of Git before. It's a lot, obviously. The first commands are not necessarily super complex, but yeah, there are still quite a long list. So as I said, don't panic. And I hope it was good enough as an introduction. Okay, Megan has the same question, so good. I haven't talked about conflicts. That's also, so on this I cannot demo it because I don't have files on my demo platform. But imagine that you made a change in a file, and on a remote server, another developer made a change on the very same files, very same line, but it's not the same change. So at the time you will try to pull the change, Git will complain and say, hey, you try to put the color blue for this button, and this person there trying to put the color green. So what should I do? So basically, it will see a conflicting change on the same line, and it will ask you to pick the one you want to adopt. So when you have this, the merging is canceled basically, and you have to edit the file, make the change. So pick green or blue, depending on what you know should be done. And then you can continue the process. So the conflicts are what happen regularly when people are working on the same thing simultaneously. And that's where rebase and merge strategy are interesting, because as I show you, when you merge, you have all the changes from a given branch, which are done through one unique commit. Whereas with rebase, we try to stack all the intermediary commit after the ones that have been done. So if you have a conflict somewhere, you will fight it on every single commit. So you will have to edit the file again and again and again for the same change, which might be painful. So that's where merging directly is easier, because you will have one single commit with all the changes. So you see all the conflict at the same time and say, okay, I pick this, and that, and now you can go. And also, yeah, I haven't mentioned it, but there are some UI to ease the work. So when you are using an IDE like Visual Code or whatever it is, there are some tooling. So with an interface, so you can see the changes, you can see the comments, and it does not impose you to use the command line options. Personally, I don't do that. I'm very fine with the command line. I feel more in control when I do that, but a lot of people are using their command from the IDE, and it might be easier. So that's, but I mean, the purpose of this talk was about the command line. So that's why I haven't mentioned that. But yeah, be aware that you might get some help from your IDE, your editor, which make it a bit better, a bit easier to get. No more question? Well, thank you all. It was a pleasure.
Thank you.
Thank you. That was very informative.
Good. You can ask me a question if you want. So I guess there were my contact information on the meeting. So yeah, if you have question, if you feel lost, I'd be happy to help if needed.
Just a quick question. How often do you commit?
How often? So it depends. It's not like about time, because sometimes it takes 2 hours to fix one line of code. So obviously once this line of code is fixed, then I commit, of course, but it's more about the amount of changes you've been doing. So I tend to do some very granular commits. So every time I change like 2 or 3 files, I would commit a change. So yeah, very, very regularly, because as I said, ultimately, it's okay, no matter how many commits have been done, and it's always helpful to get the information. And if at some point we find it too verbose, polluting the history, we can smash them into shorter series of change, basically. So yeah, don't hesitate to commit very, very often. It's fine.
I have like just a more, I guess, like, yeah, conceptual question. So you mentioned about the smashing thing, like in terms of you have too many commits and you smash it into like a less like polluted commit history. Does that kind of erase all the commits that you've done, or does it keep it somewhere, maybe like if you needed to reference it later?
Those are lost. It will create one single commit with all the comments from the commits you are smashing. Okay, so you don't lose the comments themselves, but imagine you have like 10 commits, and each of them is making a change on 1 or 3 files. At the end, what you get is one single commit with all the comments, but you don't know which comment refers to which change. So that's the information you lose. But yeah, most part of time, so something I haven't been explaining is then the process, because once you push your change to a branch on the remote server, most part of time, your teammates will review it. We usually want other people to have a look on what one developer have been doing. So they will review it, and that's where having many commits is helpful, because they can understand why you've been doing this change in this file, because there is very small commits. It's easier to review. Once it's reviewed and everybody agrees that's a good change, then maybe we don't need so many details anymore, and we decide to, on the GitHub interface, you can just merge or squash and merge, and it will squash all the commits into a single one. Because yeah, once a review is done, we can say, okay, now it's just, we can reference as a single commit for a single feature, and it's okay. Okay.
I have a question.
Yeah, sure.
So for commit messages, right? What is kind of like the best practice in like structuring that message?
Usually we try to make it short enough. If it's too long, it might be difficult to read afterwards when you are typing git log. If it's too long, it might be polluting. on if you are reviewing someone else's commit and it's super long, it might be cut depending on the interface. So it's better if it's not too long, like 1 line is good, like 80 characters maximum. Also, we are usually referencing the issue number. Like when you have something on production, you are probably using a system to list all the bugs and track them. So you have a number, so that's a bug number 1, bug number 2, and you're usually referencing this on your commit message. So it's a better way to find the issue page on the system you're using. So that's also a good practice. And yeah, the commit should explain what it does. Like not necessarily. If you do a change, like changing the button, a color on the button, and you say just commit replace green with blue, it's exactly what someone can guess by reading your code. It was blue and now it's green. So that's not adding any extra information. It's better if you say why you are doing that. So changing the design according to the last specification, or replacing the logic of the UI, blah, 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 whatever is the reason, but explaining the reason why you're doing things is also a good practice. But there are a lot of debates on that. Not everybody agrees on that, but yeah. I would say that everything that can be understood at a glance by reading the code is not necessarily useful to mention in the commit. But sometimes there is nothing else to mention. So
I see.
Yeah.
Thank you.
okay, well, we are at time now. Dana, shall I stop there? Well, I guess so. Well, thank you all for being there. It was very nice. And yeah, as I said, contact me if you need to. I'll be happy to help. Thank you all, and have a good day. Bye.